Welcome to GER Hub Mathematics and Statistics lessons. Today I'm going to be discussing matrices side by side, solving problems, but I'm going to emphasize solving problems in matrices. So if you want to understand matrices, I would suggest you go to our YouTube channel and then watch our various videos on matrices. So this video I'm making is particularly for problem solving, a part 1 to problem solving on matrices. Okay, so all I want to do in this video is just to solve or to begin solving problems in matrices. So watch our YouTube videos on matrices and you will get greater detail on what I'm doing in this video. So let's start with question number 1. Question number 1, as you can see, says determine the order of the following matrices. Determine the order of the following matrices. So the order of a matrix is simply a specification of how many rows by columns are in that matrix. So the order of a matrix is simply a specification of how many rows by columns you have in that matrix. So if, for example, if this is a matrix 4, 5, 6, 2 being the members, then I can specify or tell what order this matrix has simply by stating the number of rows. The rows are the horizontals in the matrix while the columns are the verticals. Okay, so precisely this is a row, and in this first row you have two elements 4 and 5. In the second row you have two elements 6 and 2. Similarly, these are columns, that is, the whole of this and the whole of these are columns, just like these are rows. So if you want to specify the order of a matrix, all you have to do is to write that for this matrix there are 2 rows by 2 columns. So this matrix, if I call this matrix A, then it means that the order of this matrix is 2 by 2. But we don't use this word by writing it as by. Rather, we use the symbol multiplication to represent by. So instead of writing 2 by 2 in this manner, we simply write 2 times 2. And this 2 times 2 is read as 2 by 2. Okay, so we are going to use this idea to determine the order of these matrices as required. Now let's see. For this matrix, the order is row 1, row 2, so the order will be 2 by 2 for this matrix. Why is that so? It is simply because the matrix has 2 rows and 2 columns. Okay, it has 2 rows, 1, 2, and then 2 columns. In the first row you have 3 and 0. In the second row you have 1 and 4. In the first column you have elements 3 and 1, and in the second column you have elements 0 and 4. So this matrix is of order 2 by 2 since it has 2 rows and 2 columns. Now let's move to the next problem. This matrix will be a matrix of order 2 by 3. Why is that so? It is simply because there are 2 rows here. In the first row you have elements 2, 3, and 1, and in the second row you have elements 4, 1, and 2. So there are 2 rows. How many columns do we have in this particular matrix? We have 3 columns, 1, 2, and 3. In the first column you have elements 2 and 4. In the second column you have elements 3 and 1, and in the third column you have elements 1 and 2. So that makes this matrix a 2 by 3 matrix because it has 2 rows and 1, 2, 3 columns. So in the convention for specifying the order of a matrix, rows are specified first before columns. Okay, now let's move to the third matrix. Now, like we discussed in my video on matrices, when we got to types of matrices, there was what we called a column matrix or a row matrix, otherwise known as column vector and row vector. So this is an example. Now, this matrix is a row vector or a row matrix. This is simply because it only has one row. But on the other hand, it has more than one column. It has precisely 1, 2, 3, 4 columns. So if we are to specify the order of this matrix, we are going to call it a 1 by 4 matrix. So that is a 1 by 4 matrix. Now, that's because it has just one row. In its row, you have 4, 8, 3, 5. In its column, you have 4, 8, 3, 5, occupying 4 different columns, but the same numbers occupying the same row. Now let's go to the fourth question. What could be the order of this matrix? This matrix, like we discussed in my video on matrices, this matrix is a column vector or a column matrix. And why is that so? It is simply because there are 3 rows, 1, 2, and 3, but just one column. So the name column vector comes from the fact that there is just one column, and the name column matrix also comes from the fact that there is just one column in this matrix. So if you were to specify the order of this matrix, you would first of all write the number of rows. How many rows do we have? Row 1, row 2, and row 3. So I'm going to put 3 here by how many columns? Just one column. Okay, so this matrix is of order 3 by 1. I hope that is understood. Now let's go to the last matrix here in this problem. If we are to specify the order of this matrix, let's quickly do that by identifying the number of rows. How many rows do you have? 1, row 2, and then row 3. So this matrix has 3 rows. By how many columns? 1, column 2, and then column 3. So there are 3 rows in this matrix and 3 columns, and that makes a matrix of order 3 by 3. So we had called such a matrix a square matrix in my video on matrices. So this is a typical example of a square matrix, a matrix whose number of rows equals the number of columns. Okay, so let's move to question number 2. Let's move to question number 2. To further emphasize the determination of the order of a matrix, let us look at question number 2. So the question also says, determine the order of the following matrix. So we are not going to stress what we've said earlier. Let's quickly go into determining the order. Now that we know that the order of a matrix is obtained by specifying the number of rows by columns. So this matrix has 1, 2, 3 rows, but 1, 2, 3, 4 columns. So I'm going to write here 3 for the number of rows and 4 for the number of columns. So this matrix is of order 3 by 4. For the next matrix here, we have 1, 2, 3, 4 rows. So I'm going to put here 4 by how many columns do we have? 1 and 2. So this matrix is of order 4 by 2. Okay. Now, if we move ahead to the next problem, this matrix is certainly of order 3 by 3. Why? There are 3 rows, 1, 2, and 3, and there are 3 columns, 1, 2, and 3. So this matrix is of order 3 by 3. Okay, now going to the next one, there are how many rows? Row 1, row 2. I'm going to write 2 rows by row 1, row 2, row 3, or rather column 1, column 2, column 3. There are 3 columns, so this matrix is of order 2 by 3. I hope, and I do hope, you really understand what is going on here. Just in case you don't, kindly or quickly go to YouTube videos on matrices and watch to understand what we discussed on types of matrices and the order of a matrix. So let's quickly attend to the final problem here. This matrix is a row vector or a row matrix, and that is because it has just one row. So I'm going to write here one row by how many columns? 1, 2, 3, 4. So the matrix is of order 1 by 4 since it has one row but 4 columns. Now let's go to problem number 3 on matrices. Remember, our focus in this video is to solve problems on matrices for a first time. So I'm calling it a part 1 video on solving problems on matrices. So still in our video on matrices, we have talked about location of elements in a matrix, and we use the subscript notation. Okay, so let me quickly remind you. I'm going to remind you of what we did. Now, if this is a matrix of order 2 by 2, if this is a matrix of order 2 by 2, remember in our videos on matrices, I told you that if A represents a matrix, precisely a 2 by 2 matrix, as you can see, corresponding small letters A will represent the elements in that matrix. But for us to be able to tell the difference in the position of these elements, we need to specify their location number. And specifying their location number requires that we specify the row in which an element finds itself, followed by the column. This matrix has the first element A occupying the first row. It is in the first row, so I'm going to write 1, and it is also in the first column. Do you see? So I'm going to write here A11, meaning that this element finds itself in the first row. That's the reason for the first one, and in the first column. That's the reason for the second one. So A11 means element A is in the first row, first column. This element finds itself in the first row, so I'm going to write 1. But unlike the first element, it finds itself in the second column. So it's going to be A12. This element here finds itself in the second row. So I'm going to write here 2, but it finds itself in the first column. So I'm going to write here A21, meaning it finds itself in the second row, but first column. So here I'm going to write for the fourth element here 2, 2. Of course, you can take your guess. This would be because it finds itself in the second row and second column. Now, let's bring that idea quickly to solving this problem. You would agree with me that since we are asked to specify what the elements are as we have them here, A11 in this matrix would be 3. Why? Okay, sorry. A12 will be 8. A12 will be 8. And why is that so? It is simply because A12 means or refers to the element occupying the first row but second column. So this is the first row and this is the second column. The element occupying that position is 8. So that element is A12. So the answer to the first question is 8, simply because the element occupying this position A12 is 8. If you go to the next one, what element occupies the position A23? So we seek for the element occupying the second row and third column. the second row and third column. So let's search. This is the second row where you have 4, -1 and 3. Where is the third column in that second row? This is the third column. So the point of intersection is clearly 3. So the element we seek is 3. So our answer would be 3 here, simply because the element occupying the second row and third column is 3. Now moving to A13. A13 would be the element occupying the first row but third column. So what is that element? Let's see. So we move over to the first column or the first row. The first row is this row where you have 3, 8 and -5. What is the third number in that column? It is -5. So the third column is this column, and the third number in that column is the third number in that row is -5. So in this case, our result will be -5. So -5 is the number occupying the first row but third column. Okay. Now let's move over to the next. The next is A32. A32 is the number occupying the third. It's the number occupying the third row, which is the row where you have 5, 0, 4, and the second column. So this is the second column. This is the third. This is the third row, and this is the second column. So the number we seek is 0. 0 is the number occupying the third row and second column. Okay, this is the second column. This is the third row. So our answer here will be 0. So A31 will be, by what we have done so far, I'm thinking at this point you already know the answer. What would A31 be? The number occupying the third row but first column, and that number would be what? It will be 5. So I'm going to put 5 here as our result. Then lastly, we have A33. A33 would be 4. Now I'm going to tell you, it is simply because it occupies the third row and third column. So this is the number we want. So to emphasize what we have just done, I'm going to bring up another problem. So this is still the same thing, but this will be to emphasize what we have done. Now let's see. A11, A14, A23, A34, A33, and A22 are identifications they want us to make as found in this matrix. So given that B, the matrix B is this, let's identify or determine A11. So A11 will be 5. Why? Simply because 5 is the number that occupies the first row and first column. It occupies the first row and first column. The 1, 1 means 1 is for the first row, 1 the first column. So what number occupies the first row and first column? It is 5. Now A14 is the number that occupies the first row but fourth column, and that number would be 6. So my answer here is 6. A23 is the number that occupies the second row and third column. So the number that occupies the second row and third column is this number 3, because it occupies the second row and third column. So this will be 3. A34 is the number that occupies the third row, which happens to be this row, and the fourth column, which happens to be this column here, the last column in the matrix. So this will be -1. So our result here is -1. Then the next problem is A33. A33 will be the number occupying the third row and third column. So where is that number? This is the third row, this is the third column. So the number we seek is 5. So I'm going to write 5 here. Then A22 is the number occupying the second row and second column. So where is the second row in this matrix? This is the second row and this is the second column. So the number we seek is 0. So you can see that it is very easy to identify numbers based on their position or location in any matrix using the index of each alphabet. Okay, so let's move to problem number 5. Now for problem number 5, let's see what's going on here. Now we are given 3 matrices: matrix A, matrix B, and matrix C. Now you would notice one thing about these 3 matrices, that the 3 of them are of order 2 by 2. Now if you go to our video on matrices, or our videos on matrices, precisely to the video where we talked about addition of matrices, you would come to realize that we said in that video that matrices are only conformable for addition or subtraction when the number of when they are of the same order, when they have the same order. Now clearly they want us to find the variables x, y, a, and b, provided A is equal to matrix B plus matrix C. So the first thing we are going to do in this problem is to add the matrices B and C. So let's add the matrices B and C. Remember what we said in our video, if you've watched our video, that for you to add 2 matrices that are conformable for addition, you have to add the numbers occupying similar positions together. So let's see. I'm going to write out matrix B plus matrix C, and on my right hand side I'm going to bring matrix B, which is 3, 2, minus 1, 4, and I'm going to bring also matrix C, which is 5, 1, 3, minus 2. Okay, now how do we add the matrices? We add the matrices by adding numbers in similar positions. So 3 would add to 5, and that will give us, in a new place, that will give us 3 plus 5. Why am I adding 3 to 5? It is simply because they occupy the same position in the 2 matrices. So I'm going to go to the next one. The next one is adding 2 to 1, because they occupy the same position in the 2 matrices. Then I'm going to come down here and add minus 1 to 3. So that will give me minus 1 plus 3. I'm going to add also 4 to minus 2. So this will be 4 plus minus 2. Okay? Now, on the next line, I'm going to proceed with my solution to simplifying what I have done here. 3 plus 5 will give me 8. 2 plus 1 will give me 3. Minus 1 plus 3 will give me 2. Then plus times minus is minus. So the problem reduces to 4 minus 2. And 4 minus 2 is 2. Okay? So that solves the problem of adding B to C. Now, have we solved the overall problem? No. Remember, we are asked to find what X, Y, A, and B will be if A, the matrix A, is equal to the matrix B plus C. Now, take note of one thing. You would remember in our video on equality of matrices, 2 matrices are said to be equal if they have elements occupying the respective positions in those matrices equal. So if matrix A must be equal to B plus C, then this is what we are going to have. Then it means, by what we have done, that A, which happens to be the matrix X, A, Y, B, it follows that this matrix should be equal to this matrix the matrix B plus C as we have it, the matrix B plus C, which is now 8, 3, 2, and 2. So it means we can write here, let me write it over here. I'm going to write here A is equal to X, A, Y, B, and that will be equal to the matrix B plus C, which is 8, 3, 2, 2. What does that mean? It means that X will be equal to 8. X is equal to 8. It means also that A is equal to 3. Then what would Y be? Y will be equal to 2, and B will be equal to 2. Okay, now you can of course see why. Two matrices are equal if they have the same order and the elements occupying each position in the two matrices are equal. So that solves that problem. Okay, so we've gotten X to be 8, A to be 3, Y to be 2, and B to be 2. How did we get that done? We used the idea of equality of matrices and the idea of adding matrices together. So we started with adding matrix B to C, and that was and this is how we did it. And we ended up getting our result to be 8, 3, 2, 2 for B plus C. But since we are told that A is equal to B plus C, equating A to the result B plus C means that X in A should be equal to 8, A in A should be equal to 3, Y in A should be equal to 2 in B plus C, and B in A should be equal to 2 since A is equal to B plus C. Now let's go to problem number 6. Remember, this video is all about problem solving. Now, the problem in question 6 is similar to the problem in question 5. So what did we do in question 5? What we did in question 5 is what we are going to do in question 6, only that the problem is somehow different. So, but the task remains the same. So let's see. Let A be equal to a matrix A. Let A be a matrix having P, R, Q, S as elements in the matrix. B be the matrix having elements 4, minus 3, 2, 1, and C be the matrix having elements 7, 2, 1, and minus 3. Of course, you would see clearly from these matrices that they are all conformable for addition or subtraction because they have the same order. Remember, the order of a matrix tells or specifies the number of rows by columns in that matrix. So let's see. For us to solve this problem, we would have to begin with finding or obtaining B minus C. So let's start with that. What would B minus C be? B minus C would be subtracting from the matrix B the matrix C. So I'm going to write this. Since we are subtracting the matrix C from the matrix B, I'm going to subtract this from this. Now, subtracting it gives us this result. 4 minus 7, that is this minus this, elements occupying the same position. And the next will be minus 3 minus 2. So I'm going to write here minus 3 minus 2. Then this will now be, the next will be 2 minus 1. 2 minus 1 is what I'm going to put here. And the next one will now be 1 minus 3. So I'm going to put here 1 minus 3. Okay? So we are subtracting the matrix C from the matrix B. Now 4 minus 7 would give you what? 4 minus 7 will give you minus 3. 2 minus 1 will give you 1. Minus 3 minus 2 will give you minus 5. 1 minus minus 3. Minus times minus will give you plus. So 1 minus minus 3 is equivalent to 1 plus 3. And that will give you 4 as your result. So to the problem B minus C, we have obtained the result minus 3, minus 5, 1, and 4 in a 2 by 2 matrix. Now, since we are told that A is equal to, B minus C, but A happens to be the matrix having P, R, Q, and S. Since this matrix is equal to B minus C, it means P, Q, R, S must be equal to our result minus 3, minus 5, 1, and 4. What does this mean? It means that the element P must be equal to minus 3 since they occupy similar positions. The element R will be equal to minus 5. The element Q will be equal to 1. And the element, finally, S will be equal to 4. Why are all these so? It is simply because P and minus 3 occupy the same position in the two matrices. R and minus 5 occupy the same position in the two matrices. And so follows for Q and 1, S and 4. And that solves the problem. Okay? Now, let's go to the next problem, problem number 7. Remember, in this video, it is all about solving problems on matrices, on the different concepts in matrices we are discussed in our videos on matrices. So let's see, for this problem, what are we tasked with? We are tasked with the problem of obtaining P plus Q, Q plus R, P plus R, P plus Q plus R for these matrices P, Q, and R, all of them being 2 by 2 matrices, as we had discussed earlier. So let's start with solving this problem. So I'm going to put problem A here. Problem A requires that we obtain P plus Q. So what is P plus Q? Let's bring the matrix P here. The matrix P is 7, 3, 4, and minus 2. And that adds to the matrix Q. The matrix Q is 5, minus 2, 8, and 1. Okay? So remember, to add matrices, they must be of the same order. And doing the actual addition requires that you add elements occupying similar positions. So I'm going to add 7 to 5, and that will give me 7 plus 5. I'm going to add 3 to minus 2, and that will give me 3 plus minus 2. I'm going to add 4 to 8, since they occupy similar positions, and that will give me 4 plus 8. I'm going to add minus 2 to 1, and that will give me this, minus 2 plus 1. Okay? Now, that will give 7 plus 5 gives 12. 3 plus minus 2 requires that we multiply plus and minus. Plus times minus will give you minus. So the problem reduces to 3 minus 2. And 3 minus 2 happens to be 1. Okay? So that will be 3 minus 2 over there. 4 plus 8 will give you 12. And minus 2 plus 1 will give you minus 1. So if we simplify the problem further, our result to P plus Q will be 12, 1, 12 minus 1. Okay? And that solves the very first problem, P plus Q. Now, let's move over to Q plus R. The next problem we are required to find or to solve is Q plus R. So what I'm going to bring the matrix Q over here. Let me bring the matrix for problem number B. Matrix Q comes here plus matrix R. So what is matrix Q? Matrix Q is the matrix 5, -2, 8, and 1. Matrix R, on the other hand, is the matrix this 1, 3, 0, and -4. So 1, 3, 0, and -4. I'm going to bring that matrix here. 1, 3, 0, and -4. Okay, so we are asked to add the two matrices. Now, adding them requires that we add elements occupying similar positions. So 5 would add to 1. -2 will add to 3 because they occupy similar positions. 0 would add to 8 will add to 0, and 1 will add to -4. So 1 adds to -4. Now that gives us this. So to get precisely our solution, what would our final result be? 5 will add to 1 to give 6. 5 plus 1 is 6. 8 plus 0 is 8. 8 plus 0 is 8. And -2 plus 3. -2 plus 3 would give you +1. 1 plus -4. Plus times minus is minus. So this problem reduces to 1 minus 4. And 1 minus 4 will give you -3. So that solves the second problem, B. Now, we are going to solve problem C. Now, what does problem C say? Problem C requires that we find P plus R. So problem C, for problem C, we have P plus R equals, bring the matrix P, 7, 3, 4, and -2. Bring the matrix R. The matrix R is 1, 3, 0, -4. So I hope you're following what is going on in this video. Please like, share, and subscribe to our channel. Endeavor to do that. It is very important you do that for us. That is the only way to encourage and support the channel. That is the only way to grow this channel. For more videos, if you want more videos on different topics in mathematics and statistics. So the only way to help us do that is to subscribe to our channel, share our videos, like our videos, and make comments on our videos. So let's proceed. So we are going to add this by adding 7 to 1 because they occupy the same position, similar position. 3 would add to 3. 4 would add to 0. So I'm going to have 4 plus 0 here. And then -2 would add to -4. So this will be -2 plus -4. Now, if you simplify that problem further, you are going to have your result as 7 plus 1 giving you 8. 3 plus 3 would give you 6. 4 plus 0 will give you 4. And -2 plus -4. Take note, plus times minus is minus, so the problem would reduce to -2 minus 4. And -2 minus 4 is -6. So the result of adding P to matrix R would give you 8, 6, 4, -6, another 2 by 2 matrix. Now let's go to solving the last problem. The last problem requires that we add P to Q to R, okay? We can actually do that problem by taking them in twos, but we can go straight into taking them in threes at once. So let's go to problem D. Problem D requires that we add P to Q and to R. So what is the matrix P? It is 7. The matrix P, we want to now find P plus Q plus R. So the matrix P is the matrix 7, 3, 4, minus 2. The matrix Q is the matrix, matrix Q is the matrix 5 minus 2, 8, and 1. So I'm going to bring here 5 minus 2, 8, and 1. Then lastly, the matrix R is the matrix 1, 3, 0, and minus 4. So if you add those matrices together, what it will give you is 7 would add to 7 adds to 5 and adds to 1. So the 3 will add to themselves. That will give you 7 plus 5 plus 1. 3 would add to minus 2 and to 3. So I'm going to use this. I'm going to use another pen. This will add to this and to this. So 3 adds to minus 2 and to 3. And that will give you 3 minus 2 plus 3. Then coming over here, 4 will add to 8 and would also add to 0. So that will give you 4 plus 8 plus 0. And minus 2 will add to 1 and then to minus 4. So minus 2 adds to 1 and then to minus 4. So this I'm going to show you in this manner. Now, notice that we are adding elements occupying similar positions in the three matrices at once. Now, if you simplify, this will result in 7 plus 5 plus 1 gives you 7 plus 5 is 12, 12 plus 1 is 13. 3 minus 2 is 1, 1 plus 3 is 4. Then 4 plus 8 is 12, 12 plus 0 is still 12. Minus 2 plus 1 will give you minus 1. Minus 1 minus 4 will give you minus 5. So that gives us the solution to that problem. And that ends our problem 7. Okay? Now, let's move over to problem 8. Problem 8 requires we do something similar to what we did in problem 7. So let's see. For us to solve this problem, we are given three matrices that are of order 3 by 3. Remember again, like I said earlier on, that matrices can only be added if they are conformable for addition. They can only be added if they are conformable for addition. So when conformability means agreement, if they agree for addition. Now, when do two matrices or more agree for addition or subtraction? They agree for subtraction or addition when they are of the same order. They must be of the same order. So you cannot add a 2 by 3 matrix to a 3 by 3 matrix simply because they are not of the same order. They must be of the same order if you are to add them at all, or you are to subtract one from another. Okay, so let's start with solving this problem. We are going to add in A, we are required to add X, matrix X to matrix Y. So what is matrix X? I'm going to bring it here. 3, 4, minus 2, 2, minus 3, and 5, 1, 3, and 2. That is matrix X. Adding matrix X to matrix Y. What is matrix Y? 4, 3, 6, minus 2, 5, 7, then minus 8, 6, and 3. So let's add these matrices. For us to add, we are going to add elements in similar positions. At this moment, I'm expecting you should have gotten used to the routine. So all we have to do, add elements occupying similar positions. So I'm going to do this. 3 will add to 4, and that will give me 3 plus 4. 4 will add to 3, because they occupy similar positions in the two matrices, and that will give me 4 plus 3. Minus 2 will add to 6, and that will give me minus 2 plus 6. Then let's go to the second row. 2 would add to minus 2, so this will give me 2 plus minus 2, which is the same as 2 minus 2. Minus 3 would add to 5, which is the same as minus 3 plus 5. Then 5 would add to 7, which is the same as 5 plus 7. Then 1 will add to minus 8, which is the same as 1 minus 8. 3 would add to 6, which is the same as 3 plus 6. And 2 will add to 3, which is the same as 2 plus 3. So just follow what I'm doing. I'm actually adding in the matrix X elements that occupy the same position as those in the matrix Y. So what would my result give? Summarily, 3 plus 4 gives 7. 4 plus 3 gives 7. Minus 2 plus 6 will give you that will give you 4. Okay. 2 minus 2 will give you 0. Minus 3 plus 5 will give you that will give you 2, positive 2. 5 plus 7 will give you 12. 1 minus 8 will give you minus 7. 3 plus 6 will give you 9. And finally, 2 plus 3 will give you 5. So this is the result we are going to get to x plus y, adding x to y, okay? Now, let's move to the next problem. The next problem demands that we add the matrices x and z. So I'm going to bring problem B here. It requires that we add x and z together. So what is the matrix X? I'm going to bring the matrix X here, and I'm going to bring the matrix Z here. So the matrix X is 3, 4, minus 2, 2 minus 3, 5, 1, 3, and 2. While the matrix Z is the matrix 1, 3, minus 3, 1, 4, 4, 2, 6, and minus 5. Okay, so let's add these two matrices together. It is the same thing we've done, and that will give us adding 3 to 1, adding 4 to 3. Why am I adding those elements? It's simply because they occupy the same position in the two matrices. So, or similar position in the two matrices. So minus 2 will add to minus 3. You have minus 2 minus 3. Then coming over to the second row, 2 would add to 1. Minus 3 would add to 4. So I'm going to have here minus 3 plus 4. 5 would add to 4, and that will give me 5 plus 4. And then 1 will add to 2. This will give me 1 plus 2. 3 will add to 6. This will give me 3 plus 6. And 2 would add to minus 5. And that will give me 2 minus 5. Okay? So, to round up our solution, we are going to have this. We are going to have, summarily, x plus z giving us 3 plus 1 is 4. 4 plus 3 will give you 7. Minus 2 minus 3 will give you minus 5. 2 plus 1 will give you 3. Minus 3 plus 1 will give you 1. 5 plus 4 will give you 9. And 1 plus 2 will give you 3. 3 plus 6 will give you 9. And finally, 2 minus 5 will give you minus 3. So that solves that problem. So let's move to the third problem now. The third problem is actually obtaining y plus z. So let's see, for y plus z being the third problem, what do we want? We are going to write the matrix y. The matrix y is 4, 3, 6, minus 2, 5, 7, minus 8, 6, 3, and that will add to the matrix z. What's the matrix z? The matrix z is, let me move this over to the side. So the matrix z, as we had it earlier on, is 1, 3, minus 3, 1, 4, 4, 2, 6, and minus 5. So this is the matrix Z, okay, as we have it in the problem. So we are to add y to z. Now let's proceed with the addition. So remember, we are still adding elements occupying similar positions, and that will give you 4 plus 1. That gives 4 plus 1. 3 plus 3. 6 plus minus 3. Minus 2 plus 1. 5 plus 4. 7 plus 4. Minus 8 plus 2. 6 plus 6. 3 minus 5, or 3 plus minus 5. Okay, now it will simplify to 4 plus 1 gives 5, 3 plus 3 gives 6, 6 plus minus 3 will give you 6 minus 3, because plus multiplies minus to give minus. So 6 minus 3 is what we have, and that will give 3. Minus 2 plus 1 is minus 1. 5 plus 4 will give you 9. 7 plus 4 will give you 11. And then minus 8 plus 2 will give you minus 6. 6 plus 6 will give you 12. 3 plus minus 5 reduces to 3 minus 5. And that's because plus multiplies minus to give minus. So 3 minus 5 will give you minus 2, okay? And that solves the problem. The last problem we are going to solve is the problem D. The problem D requires that we add x to y and to z. So I'm going to write the three matrices x plus y plus z. So what is the matrix x? The matrix x is 3, 4, minus 2, 2, minus 3, 5, 1, 3, and 2. The matrix y is the matrix 4, 3, 6, minus 2, 5, 7, minus 8, 6, 3, and then lastly 1, 3, minus 3, 1, 4, 4 for z, 2, 6, and minus 5, all in the matrix z. Now that will add to give us our final result. So let's see, 3 would add to 4 and 1. So that will be 3 plus 4 plus 1 in the three matrices. And that's simply because we are adding matrix elements occupying the same or similar position. So 4 would add to 3 and to 3. So this will give me 4 plus 3 plus 3. Minus 2 would add to 6 and minus 3. So this will be minus 2 plus 6 minus 3. 2 would add to minus 2 and 1. So this will be 2 minus 2 plus 1. Minus 3 would add to 5 and to 4 in the second row. So that will be minus 3 plus 5 plus 4. Then 5 would add to 7 and to 4. So this will give 5 plus 7 plus 4. Then lastly, 1 will add to minus 8 and 2. So that will be 1 minus 8 plus 2. And 3 would add to 6 and to 6. So this will be 3 plus 6 plus 6. Then finally, 2 would add to 3 and to minus 5, and that will give us 2 plus 3 minus 5. So if you simplify that, you would end up having this. 3 plus 4 plus 1 will give you 8. 4 plus 3 plus 3 will give you, 10. Minus 2 minus 6 is 4. 4 minus 3 is 1. So you have that for the first row. For the second row, 2 minus 2 is 0. 0 plus 1 is 1. So I'm going to write 1 there. Minus 3 plus 5 will give you 2. 2 will add to this 4 here to give you 6. Then 5 plus 7 is 12. 12 plus 4 is, that will give you 16. So altogether you have 16 over here. 1 minus 8 will give you minus 7. Minus 7 would add to 2 to give you minus 5. Then 3 plus 6 is 9. 9 plus 6 is 15. 2 plus 3 will give you 5. 5 minus 5 will give you 0. So this will be the solution to x plus y plus z. So thank you for watching this video on a part 1 to solving problems of matrices. We are going to continue with this problem solving process on matrices in a part 2 video. Watch out for that by clicking on the notification bell, and I will see you all in a bit. Thank you.